Thomas, sine of 20 about you're looking at the unit circle? Where do you see 20 degrees on the unit circle? On the right? Where is it relative to 30 degrees? Where do I find the sine of 20 on that diagram? What does it say in your unit circle? Where do I find the sine of an angle? Do you see a parentheses with sine and cosine on your unit circle there? Which goes where? So where do I find the sine value when I'm looking at a point? The y value. So can you look at your graph or your circle and can you estimate that length right there? A half? How tall is that, Thomas? That's a half, yeah. So, what fraction is this? If this is a half, how much of that? 3/4 of a half? Does 3/4 of a half seem reasonable to you guys?
Yeah.
Because we're guessing. It's an estimate. If this height is about 3/4 of that height, then the sine of 20 is about 3/4 of a half. What's 3/4 of a half, Thomas? That's a 3. What? What's 3/4 of a half? Razzie, you want to help him? 3/4 of a half? 3/8. Right? 3 times 1, 4 times 2. And it's a decimal, that's 0.375. Get out your calculators. Type in sine of 20. How close are we?
We're going to be back in the dot.
Do not, however, type in the cosine of 20. Sine of 20. Ryman?
It's 0.91.
Doubt it. I seriously doubt that the sine of 20 is 0.91 because, hang on just a second, because this is one of these situations where you say the stupidest thing that anyone could ever imagine, and because my calculator said it, by golly, it must be true.
No, it's in radians.
Oh, because hang on a second, Megan, if the sine of 20 were 0.91, then 20 degrees would have to be up here on my unit circle.
figured it out.
You figured it out after
Yes.
you told me the wrong answer. It's a good idea to figure out that you've got the wrong answer before you tell everybody. That way they don't all look at you and go, what on earth are you talking about? Because this is a good object lesson, and I'm happy actually that Ryman and Jesus were like, yeah, that's it. Because it's really, really important that you have an idea of what your answer is supposed to be before you start typing in your calculator. Because if you do something wrong in your calculator, you know who is not going to catch the mistake you made in your calculator?
The calculator.
The calculator, exactly. Calculators are good at one thing and one thing only. They're really good at doing exactly what you tell them to do really fast. They are not good at understanding what you meant to tell them to do, as it turns out. So yeah, we know that this has to be something less than a half. The question is how much less than a half? Megan, what is the sign of 20?
0.342.
Hey, that's not a bad guess, Thomas. Not a bad guess. Cosine of 20, which you have not checked in your calculator yet, because you wouldn't do that. Macia, estimate. First off, where do I find the cosine of 20 here? Good. Right here, cosine. What fraction of our length would you say that we have on our 20 degrees? How long is it from the center all the way to here? About one? Or exactly one? Yeah. All the way to the circle is exactly one. So Macia, give me a guess. Give me a guess as to where that, on when you look at your unit circle and you estimated where 20 was, and you drew straight down to make your right triangle, give me an estimate of a decimal that would be this length from here to there. Okay? So Macia's estimate of the cosine of 20 is about 0.9. It is now time for what?
Check.
Calculators. Go. Cosine of 20.
Yeah, that's what I got. 93, 96, 92, 16, 0.
Cosine of 20, actually 3 decimals, Ryman.
0.939.
Hey, that's not bad for a guess. Ryan?
I was just saying, would it be 0.94? Because the last thing is a 6, so I'd round the 9 up.
Yes,
I'm not sure how.
No.
No, okay.
No. No. You do not start at the very bottom and then keep rounding and rounding and rounding and rounding. You decide how many decimals you want and you only look at the next decimal.
Okay. So,
wait, because he gave me 3 decimals.
yeah.
Yes, exactly. Yeah, I misunderstood what you were saying. If you are rounding this to 3 decimals, then yes, the 6 rounds the 9 up. And since that rounds to 10, this would round to 0.94. But
We put a 0 after that?
yes, because you're at 3 decimals. Yeah, sorry, I completely misunderstood what it was you were saying. But yeah, you don't, like for example, if this was 4/7 and you wanted this many decimals, you don't round the 7 to a 5 and then say, aha, the 5 rounds that to a 7, because that is less than 5. So if you wanted 4 decimals, this would be 936, what I have written on the board. Does that make sense? That's what I was thinking when he said that. So, yeah. Okay? Okay, what was the point of this warm-up? The point of this warm-up is to recognize that there are all these values on this unit circle. There are an infinite number of angles on this unit circle between 0 and 360. Guys, only a few of them have exact values. Only a few of them are special. 30 degrees, special. 20 degrees, not so much. But it's there. It just isn't one of the special exact values. This is just a confusion that sometimes people run into, is that they look at the unit circle and they say, oh, well, we got 30 and we got 45 and we got 60. And then someone says 20 and the answer is, but 20 is not on the unit circle. Well, yeah, it is. It's right there, just below 30. And we can use that to estimate, because we know that the radius is 1. But we just don't have an exact value for 20 degrees. That makes sense? We good with that? Okay. Cool. Without graphing cosine in your calculator or your Desmos, without, that means don't. Okay. I want you to make a table of values from your unit circle. 0, 30, 45, 60, 90, 120, 135, 150, 180, and so on, all the way to 360. Decimal, 2 decimal places. Oops, 2 decimal. I don't know why I did that. 2 decimal places. And on that graph I gave you yesterday that you graph sine on, flip it over and look at the other side. Not the unit circle, the graph.
That's my graph.
That's her graph.
It's still a graph.
There is a blank graph for you to graph cosine. So, make a table, plot all these values, graph cosine. Go. All the way to 360, including all of the special values on that unit circle.
Wait, you said Penny does one, right?
I just want you to actually make a graph instead of like, because we could just, yeah, we could shove it into our calculators and it would show us the graph of cosine, but I don't want you to just see it. I want you to actually make it and then we'll look at it. It will mean more as you think about where these values came from at every single point on the unit circle. Okay? By the way, you've already done the calculations for the decimals.
So he already knows.
You don't have to recalculate them all.
And then square root of 6.7. That's a half. You're going to figure them out again.
Yeah. Let's see that. Do the same thing. Good. crazy man.
Maybe. Why do you guys so hard?
Hmm?
You guys are like this. I forgot my thing.
Uh-oh. Cosine started at 0.
How's that make sense? What did you do? How did you get
Cosine started here, right? That way.
Did you put in the content?
So it's gonna start at 1, and then the rest of you,
What?
except it started
How did you get it then?
It's just an estimated,
Everything else looks good.
because obviously this is a half.
Where's your graph?
Square root of 2 over 2 is gonna be bigger.
Oh, likely story.
And square root of 3 over 2 is gonna be bigger than half.
What?
Yeah,
Oh, because you
What?
do the X now.
You also got the
Yeah.
square root of the table?
Don't
Have it up.
You got this?
Well, this is honors.
how do you not understand? Maybe?
No, I understand.
You understand?
Yeah, I fully understand.
Wow. Hey, hey,
Megan, you did it wrong.
hey, Megan, what's the cosine of 90?
It's gonna be bigger.
0.
Yeah, but you plotted it,
Oh, I plotted it
Up
up
to
here.
1.
Oh, oopsies, oopsies, that's my bad. That's my
and
bad.
then what's the cosine of 120?
Negative. Oh.
Oh, there you go.
See, so why not?
So now, sorry, Jesus. Say it.
Sorry.
Sorry, Jesus.
Sorry, Jesus.
Thank you.
So, Jesus, what are you doing? I see your sine graph. Now what?
I did the same thing on both sides on accident. No, this is the sign. This is the sign.
But you know what? I think your other sine graph is way nicer. Look at that weirdness.
Really?
Yeah, see how that other side doesn't have that weirdness there? It comes down and then it curves and goes back up again instead of having that little down and off. Oh, I don't care. Make sure you look at one video and one side. And, put it in your pocket when you laugh. You know, at least your notebook. Too bad it doesn't have a handy little pocket to put things you want to keep in good shape, huh? That would be super
B
convenient.
minus is passing.
Well, the manufacturer, hey, look, put a little pocket in the notebook. Oh, okay, good. Good, I like it, I like it, I like it. Very nice.
Let me see.
Well, here's the problem.
Thank you.
Tell me about the cosine of this angle. It's the x value, right? What do you know about the x value?
Huh? Thank you. I know, right? My handwriting is insane. And it transfers over to crap.
And
Crap.
this is 1, what's the best? Make sense? All right, guys, you may now go into your calculator and type in y equals cosine of x, and assuming that you didn't reset all your settings from yesterday, you should get a beautiful cosine graph in your calculator, which you can compare to your drawing, after which you can look at your drawing and just say to yourself, oh my gosh, I am so good at this.
I am so good at this.
I think that's not right.
Cosine of
I think that if you're using the graphing calculator on your Chromebook, it did not keep all your settings.
I changed it.
Because
all
every
settings.
time you bring the app back up, it's just like a brand new app that it's never seen before.
Well,
You have to change the window.
Oh, look at mine.
You have to change the
Oh, yeah.
window. Hey, you listening? You have to change it to degrees, not radians.
Oh, the zero.
Or you can just do it on your calculator since it's right there.
It's too lazy to get it.
I know, reaching all the way into your backpack.
That's too much. That's
Yes.
calories I'm losing.
It is.
It's calories I'm losing.
I need to reach into a backpack three
It's
or
the same
400 more
thing.
times. Because you didn't change the settings.
What am I supposed to change on here?
Same stuff we did yesterday. What did we do yesterday?
We
It was
changed
just
it
the
to
window
radians.
and the.
No, we didn't just change it to radians, from radians to degrees. We also changed the window.
Oh, to 360.
Yes, the 360, right.
The X.
Hey guys, just a reminder, changing the window in your graphing calculator is just like deciding what your scale should be when you're drawing a graph on your page. You would never just draw a 10 by 10 by 10 by 10 graph on your page and then try to graph this data. You would say, oh wait, my x's need to go to 360. You've got to do the same thing on the calculator. You decide what your axes need to be, you change the window settings, and then you put in your graph.
So my X needs to go to 360.
They both need to go to X
And
360?
then negative 90.
Well, x definitely needs to go to 360. What is your cosine? What are the minimum max values cosine,
That's what I
Jesus?
get when
I'm
I
so
just
good
got a
at
flag
this.
dog.
I got it to work.
What?
I don't like your. I bet you're still in radians.
Probably.
You push the mode button and change it to degrees. You're just ridiculous.
Mine's perfect. Mine's perfect.
Why did you put y to 360, Jesus?
Well,
What's the minimum and maximum values of y on your table?
1 and negative 1.
There you go. If you go to 360, you're not even going to be able to see the graph.
Wait.
No.
Don't worry, you can do it. I got this.
I know you do. I have faith. I just wish you'd do it before I yelled at you.
Well, is it because I think I have it right and then it's not right? Oh, there you go. It's supposed to look like that, right?
That's beautiful.
So does it?
Yeah.
Okay, so if we're doing degrees, right? It's sort of
Yeah.
You can't have a negative. Wait. You can't have a negative X value, right?
Okay, whoa, hang on just a second. Hang on just a second. I had a really good question.
That's a perfect circle.
My unit circle starts at 0 and it goes around and it ends at 360. What happens if I keep going after I've gone once around? Where's the next place that I get to?
61.
Yeah, 361 if I'm just thinking about whole numbers. Agreed? Now, what if I went back to 0 and I went that way? What would happen?
Negative? Maybe?
There's -1 degree. Negative degree just means that instead of going around clockwise, I decided to go around. No, wait. Instead of going around counterclockwise, I decided to go around clockwise. Does that make sense? So yeah, we can have negative values of x in our sine and our cosine. Okay. All right. Here's what I want you to do next. Oh, Mr. Armring, there's a next, but of course there's a next. New table.
Dogs.
Oh. 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 Tangent.
Tangent.
Now, stop for just a second. You will not type y equals tan of x into your calculator. You will not type y equals tan of x into Desmos. You will not Google search y equals tan of x graph. You will instead make a table and graph it. Where?
Yeah.
On a graph would be my suggestion.
Like.
You'll have to make your own. That okay. I was like, I don't know why she's asking me where we graph stuff. We get a piece of paper and oh, I get it. Because on sine and cosine, I gave you a set of axes. Yes, this one you can do in your notebook. If you don't have a notebook, you can get a piece of paper from the stack of graph paper at the back, or if your notebook doesn't have graph paper in it. All right? So what? Ask. I'll answer.
So we just do
Y equals
for
tan of
90
x.
degrees. It's 0 and 1. So you just do.
Should I even?
That's 0.
Okay.
Can we get our answers?
For 90 degrees, yes, I guess.
Is that an x?
Okay, I was just wondering if that's.
Wouldn't that be
Do that for every degree.
What?
Because y and tan of x,
What?
you know?
Why would it be y?
Because y equals tan of x. It's just y equals, no? It is. On the way.
I think something about that story. There's like a small joker.
Oh.
You said no.
What? Low-key confused.
Hey, let me make it even more fun. If you're using the tangent button, stop. Oh,
What tangent button?
exactly. There is no tangent button.
Okay.
The tangent button on your calculator just broke.
I have one.
If you'd like, I could come over with a pocket knife and pry it off. It's broken, Maris. It doesn't work anymore. How would you calculate tangent for each of those values if the tangent button were broken?
What do you see here?
I'd look at May's paper.
What?
It's not tangent. No? Come on, Mark.
Jesus, work. No,
Excuse me.
no.
Alright. Oh, yeah.
Where's my unit circle?
Yeah, I'm gonna just copy out these, or just copy out the rest.
So how do you find tangent? What's tangent button breaks? We'll go back in your notes. We talked about it. You may even have written it on your unit circle.
We did?
We did this like last week,
Oh,
I think I could be wrong though. I don't know that one. Yeah, yeah, wait.
Wait, explain. Thought process, explain.
I don't know what that is though, as a decimal.
Explain. Where are you getting this from?
We did it.
Okay, and then what are you gonna do for the rest? You have like 4.
Yep.
You got like that?
Merits. Yeah, I think it's divided by a slope, and that line right there.
What is this?
No, we're just getting one.
Oh, in a certain way. So, tangent is opposite of hypotenuse, right? The opposite. Divided by.
Exactly.
I mean, no, tangent is opposite over each other. So you do opposite, which is.
I told you.
See, okay, I was losing my bedside.
That number is a slope.
Okay, what's this as a decimal? A decimal? A decimal?
Just don't put decimal. I know you think it is.
Well, how about you stop?
But I need
When I
this
said
as,
your tangent button broke.
I need this as a decimal.
Mhm.
Oh wait, no.
I don't know.
Wait, you have tangent?
Hey, what are you doing?
The tangent of 0 is 0, correct?
Divided by.
What do you call it? 1? How do you know 4 times 1?
I think that's wrong.
How would you divide?
No, I think that's right. I
Oh,
lied.
that's kind
I think that's right.
I don't think it is.
Maybe? I don't know.
Probably isn't.
Probably not. Probably not.
1/5 divided by square root of 3 divided by 2. That's not gonna work.
Why not?
That's too much.
I don't think so. What do you get?
0.408.
Oh.
Use parentheses.
Did you close the parentheses on the 3 to tell it to stop taking the square root?
That's probably a good idea.
Yeah.
Why did I do that?
Did you remember to put a divided by in there?
Wait.
Yeah, put a divided by in here.
Redo it.
You know the insert button? Right there above the delete.
What does that do?
Insert things. So if you wanted to like shove a divided by into the equation, you wouldn't have to redo the whole thing.
I've always had to redo the whole equation. Is it 0.14?
Yeah. What's the slope of that line right there?
1.7?
Oh,
That's.
It is? I feel like that's a slope of 0. What's that? That's a
You
slope.
Oh,
of
did-
see,
that?
no,
you did something-
no,
Rise.
it's because,
You did.
no, you forgot to
What's
finish the
rise?
parentheses on the square root of 3/2.
There isn't one, so it's.
Oh, the only thing getting square root is the
Dog,
3. The
dog,
only thing getting
dog,
square root is the
dog,
3.
Dog,
He
dog,
signed it.
you're also doing a different thing.
We're both doing 30.
Yeah, I was doing.
I was doing 30.
You were doing 30?
I was
Are you
doing
sure you're
30.
doing 30?
Look at the equations.
Are you sure you're doing 30?
I swear.
You actually wrote 1 divided by 0.
Coach signed me up. And plus, you put 1.7, not 0.5. You literally got 0.5.
Yeah, because it's the other one.
There you go.
Huh?
So if you have a degree,
Uh-uh.
All right,
Uh-huh.
where's graph?
uh-huh,
Go.
opposite over adjacent.
Yeah.
Yeah,
Yeah.
yeah. So it's,
It's this one.
Okay, okay.
See?
Alright.
Yeah.
Let's go. Verbal
so
instruction.
does it when I
All right, nice, where's your graph?
Oh, yeah.
Oh.
I already have a headache.
Oh.
Come on, Mark.
I actually don't know.
I've done my graph. You can do your graph.
I think this is still one, 45.
Then you look a little.
Yeah, so you do.
Yeah, because if this went from 0.5 down to 0.71, down to 0.87, down to.
Ben
1,
Willis. That's your last name, isn't it?
Up to 0.87, right?
Willis?
Yeah, so those two should be.
Willen.
Willen.
I think they got 0.55.
And Willen.
So bad. We got 0.57, so it's basically the same thing. No, leave it, because I had the other one, 2 decimal places, and you have to make one
I still
decimal
have
place.
0.7.
Just leave it, that's mess things up.
You do it, you do it,
Look.
you do it.
Look.
You do it.
Hey, watch.
No, for the next one, and this one.
That one?
Yeah.
Square root. No. Divided by square root.
So you're doing this one again.
Oh, we're doing this one?
Yeah, do that one.
The square root of 3 divided by 2.
What did you
I don't know, that's the second time it's happening. The square root of 3 divided by 2 divided by 0.5.
And then you might think, or we should have negative slope.
So then you divide by
Is it just an
divided by 0.5.
Negative or positive.
Dog, that's literally the exact same thing.
Okay, no, because we did it wrong. Watch. It's supposed to be like this. The square root of 3 divided by 2 divided by
Have to be
0.5.
positive.
Damn, I guess it is.
It is the same thing.
Nice, what'd you get for 45? Or not 45, for 60.
How we doing?
Oh, okay, see, I told
We
you.
drew a set of
Okay,
axes before
dog.
we even have a table of the values to put
Dog.
on our set of axes.
Hot dog, diggity dog. Yay.
Really, we're just now starting.
Is this a game?
I gave you this thing to do like 10 minutes ago. Maybe wrong.
Wait, so square, oh, so then this is just negative
Divided by
of that one, of the negative 1.7.
Do you have any oranges, Max?
One? Yeah.
You got any daisies and stuff?
But divided by works.
Like the flowers?
This is, yeah, no, okay, anyways.
Good.
I think this is, right? Wait, that's
I got
not,
like pretty much half of
You have
it.
to, exactly, now you need to calculate.
Once you
Okay,
do
well, I
like
lied. I
the
don't even
first
have
thing.
Oh, darn it.
It was 90.
What do you mean, what is 90? 90 is an error.
1 divided by 0 is 90, right? An error. No, that's cat. Okay.
Yeah.
What we doing?
I was gonna say, Maris,
Can I see your book?
can I see your book?
Can I see your book? Spanish.
I'm looking for fun. I like
I hate them so much. I hate them. I'll literally be in first place and then I'll go straight down
That's
the
why I
road.
got swap. I was on the second one because if I don't know, then I'll automatically.
Higher slow, higher
I
slow.
get clapped every time.
Medium, low.
So
this goes low.
Well, I remember
Go high.
one time I got in, there was like 2 kids left. I got in there later. There was like 2 kids left.
Oh, no,
Is this
Boom, straight second place. Somebody stole all your goals. I was down to like 10 goals.
That is a true statement. And then, yeah, same here, it should be up here. So,
All those games are
really, grab more like that.
It's a whole new game.
Okay, now I need to graph this.
Should we actually need to graph it? I'm sorry.
It's just not big enough.
Oh.
Yeah, it's not
Yeah.
sorry.
Of course you do,
Oh.
Morris.
Can I do it on this
It's
graph?
like,
I'm scared to grab it actually.
Where
I'm
would
not scared
where?
of the word.
Can I do it on this?
won't be big enough, throw it in your page.
Oh, it's a
So
drawing.
look at your values. You go
It's-
from 173,
Yeah,
it goes up to
I
1.
just think I'm.
Draw, graph, come on.
The one playing?
Anytime, you wasted
What?
time. That was hours ago.
Is it negative?
Don't copy, because I don't know if that's right.
It's okay, we're teammates. I'm chilling. I wouldn't even get it right.
How do I even make this go?
No.
90. 180. 270. 360. Okay, now.
So before you hit enter on that, don't hit enter, put close parentheses and then don't hit enter. What do you think sine
Turn it
of
over here a little bit.
45 divided by cosine of 45 is gonna be equal to?
Why do you put negative 0?
So you don't really even need to go through the whole annoying
doesn't matter
process
what you
of typing
put.
it into your calculator, do that. Now, the other two,
Wait,
you
this
know,
has to go
I
higher.
agree with you that that's hard because you don't know what
Show
that is
you
as
a
a
life
decimal
hack.
and get it there. But this one, it's like, oh, look, one.
Oh,
Moving on.
Wait,
Next
okay.
thing.
you can't even
No.
move.
I gotta redo it. Which kind of sucks. 2. 4, 5,
Oh, these people are just starting to bother graphics. Makes me so sad.
Don't judge. I messed up on the first one.
I'm not judging, I'm just sort of, okay, yes.
Yes. What's that one? 20.
I just expect better from my honors classes.
Oh.
I think we're your, like, actually not as cat. This is because me and
Okay.
Speaking of which, here's this, you're gonna turn in some homework soon, because it's been a few days. And you're
I turned one
great.
in today.
Oh, did you? Okay, I haven't graded, I've been teaching all morning, so,
Yeah.
okay. I just worried because I've been watching it slide down and go back up again.
When you're not, I turned it in today.
Good.
I think
Glad to
this
hear
is
it.
wrong.
Holy.
I was.
Really?
No,
You were laughing with me?
Jesus, work.
would you tell me if it's
3, 4, no, it's 5.
What about 5 minutes?
And it had.
Nate, people are trying to work.
Oh, I gotta go negative too. Gosh dang it.
What, 150?
Don't judge me.
All right, guys, I want everyone looking up front. Let's do a little bit of thinking very quickly about tangent. What's the slope of this line? 0. Agreed?
Oh, that was you with your arms. Okay.
What's the slope of this line? 45 degrees, right?
Yeah.
What's the slope of this line?
0.
It is undefined. 0 is here. Rise over run. No rise, as much run as you want, that's a slope of 0. Rise over run. As much run as you want, as much rise as you want, but no run, that's undefined. It is not infinite. Infinite means you have a very, very large number. This does not have a large number slope. It is undefined because you don't have any run. You can go up as much as you want. Pick 2 points on that line. Goes up as much or as little as you want. And when you try to divide it by the run, the x change, there is no x change. The slope is undefined. Guys, what happens on graphs when we're dividing by 0?
There's a hole.
No. And no. It doesn't work as a meaningless statement. And there is a hole. That is not strictly a true statement. When do we get a hole in a graph, Jesus?
Not go back to my notes in a second.
Anybody? Say again? When we divide 0 by itself. In other words, when we have a 1. Agreed? A 1 creates a hole. Do we have a hole in the graph at 90 degrees? Are we dividing something by itself? Simple question. At 90 degrees, we are dividing sine of 90 by cosine of 90. We are dividing 1 by 0. That is not a 1 that creates a hole. Agreed? So what happens when we divide by 0, but there's not a 1 there? There's an asymptote. See how everything's related? The theory of interconnectedness. If you divide by 0 and it doesn't create a hole, in other words, there's not something divided by itself, you get an asymptote on the graph, always. At 90 degrees, there will be an asymptote on the graph. What's the tangent of 30? Somebody? I'm going to call it about 0.6 because my graph isn't that accurate. What's the tangent of 60?
They rounded.
Guys, do we agree that another way to think about the tangent of 60 is it's just 1 over the tangent of 30 because the sine and the cosine switch values? 1 over 0.6 is about 1 2/3. And we have an asymptote. Now, what happens on the other side of the asymptote? What's the slope at 180? Zero. What's the slope at 135? -1. What is the slope? Where was I? What happens to the slope as I get closer and closer and closer to 90? getting bigger negative, right? Agreed? Guys, when I'm looking at a line and it's got a positive slope and that slope is getting bigger and bigger and bigger and bigger the closer I get to 90, and I get to 90 and it's undefined, and now it's just a really big negative and it starts getting smaller and smaller and smaller and smaller negative, agreed? Until it gets to 180 where it's 0, and then what happens? After 180, starts going back up positive again, right? Guys, if you think of tangent as a slope, you look at an angle and you say, what's the slope of that line? Well, sure, but maybe. Or maybe that's 47 degrees. But if you think of tangent as a slope, you can look at this and you can say, oh, look, the slope keeps getting bigger and bigger and bigger until it hits an undefined. And then it's going to be negative and get smaller and smaller and smaller until it gets to 0. And then it's going to start getting bigger and bigger and bigger again until it gets to another asymptote. One of the things that I really want you guys to do is start thinking about these relationships. When I said to you, make a graph or make a table and a graph of tangent, I had a lot of people sitting there thinking or saying to themselves, well, I don't know what to do, and not doing anything. But we should be able to look at this and we should be able to say, well, hang on a second, what do I know about tangent? And so instead of sitting here claiming I don't know what to do, think to yourself, well, what do I know about tangent? Well, thing one, I know that tangent is slope, because that goes all the way back to geometry. Thing two, I know that tangent is sine divided by cosine, because we already talked about that, and I wrote it down on my unit circle. And thing three, I've got tables of sine and cosine, but I don't need to sit and type every single one of them into my calculator because they're obvious. Oh, look, there's one that's 1. Oh, look, there's one that's 0. But this requires that when you think about this idea that you say to yourself, well, what do I know? Not just I will start just randomly writing down numbers on a thing and they won't mean anything to me. As you have to, and the reason I'm telling you this is because I'm assuming that most of you are going to be moving on in math. You have to think about what a problem means when you start thinking about the problem. Because if you look at every math problem as just some sort of random thing that you type into your calculator and start copying stuff down, this is going to be very difficult for you. You have to think about what it means. Think about all the functions that we investigated. Why did we investigate parabolas at such length? So that when you see something parabolic, you'd say to yourself, oh, hang on a second, I've got a parabolic function here. I know all about these parabolic functions. If I were to, or somebody else were to just write on the board, y equals 2 parentheses x minus Jesus, listening please, plus 4, and say, tell me about that, and you were to go, well, when I type it into my calculator, I get, and start spewing out numbers, you wouldn't do that. You'd say to yourself, well, hang on a second, I know that this is a parabola, and I know that the vertex is at 1.54, and I know that it's going up twice as fast. Boom. You've told me everything there is about that shape. And you haven't just said, here's a list of numbers that go with that equation. Because honestly, I train a monkey to generate a list of numbers. But what I want you guys doing as you move forward is I really want you, when you see a math problem, think to yourself, what do I know about this? And don't start with, well, I could spew out a list of numbers, but instead you think to yourself, what do I know about that list of numbers? Hey, guess what? I don't even need to spew out a list of numbers because I already know these ones. I already know the shape. I already know the quick graphs. I already know the vertex. I know everything there is to know about that equation. Tangent should have been the same thing. The reason I stopped you before a lot of you got through your graphs is because what I was seeing is I was seeing a lot of people not thinking about what tangent was, but instead just writing down a bunch of numbers and then sitting there and trying to stick them onto a graph, as opposed to stopping for a second and thinking to yourself, well, hang on a second, what do I know about this function? Oh my gosh, it's slope and it's the ratio of sine and cosine. And if I think about it as slope, I already know half of the numbers on this graph. Because I know this one and I know that one and I know that one. And if I know those three, that means I know this one and I know that one and I know this one and I know that one and I know this one and I know that one. Boom. You've got more than half of the numbers on there. And then the fact that these are related, that this one is a reciprocal of that one because you just switch sine and cosine. Make that table, draw that graph. If you stop and think about it before you start, it becomes a 5-minute process. I don't know how much time we spent on it, but think about this moving forward. I don't care about the time. I mean, I'm here to just teach you, what we can learn in the time we have available. So that's not the issue. The issue isn't, oh my gosh, you guys wasted time. The issue is that you wasted your time if this had been a problem that you were trying to figure out. If this had been a problem that you sat down one day and said, okay, I want to figure out this math problem. You want to be efficient, and one way to be really efficient at these things is to start by saying, what do I know about this? Now let's go from there. Does that make sense? Guys, we cool with that? Okay. Excellent. Excellent. Now, what I do not expect to have happen is somebody come wandering in my classroom and say, hey, the folks in honors math said you were really mad at them. Because I've had that happen before where I was like trying to explain something to people and then they went away and they're like, oh my gosh, Mr. Armour, you're totally yelling at them. They're like, wait, no, I wasn't. I was just trying to explain stuff. So. All right, so hopefully none of you are sitting here thinking, oh my gosh, he's so mad at us. I want you to get better at this and I want you to have these tools and understandings moving forward. Okay? We good? Awesome. All right. I'm mad at Hayes though.
Always.
What do I want to talk about? Hang on a second. Let me pause for just a second and grab my notes. Oh, I know what's next. All right. Let's talk about unit conversions. Have I told you guys about the bridge method?
No. Pretty sure that's in physics.
I don't even know where to go with that. Is there somehow in your mind this idea that physics is one thing and math is another thing and never the twain shall meet?
Yeah, when you say if there's two different classes, they're definitely not the same.
Definitely totally unrelated to each other, yeah. Guys, let's talk about the bridge method. It's 150 miles from my house to Seattle. And I want to know how far it is in kilometers. And I know that there are 1.62 kilometers in 1 mile. So that means that I either need to multiply 150 by 1.62 or I need to divide 160 by 1.62. One of the two. And I always get confused and I can never remember which it is. Now, the statement that I just made is something that I see on a regular basis with my high school students. Not necessarily you guys, but I see it on a regular basis with my high school students. Convert feet to inches. Well, I know that I'm either supposed to, I know it's something to do with a 12, but I'm never quite sure whether to multiply by 12 or to divide by 12. The bridge method eliminates the confusion. Now, in this particular case, you're probably thinking to yourself correctly that I don't really have any confusion because this is a really simple one. But as the problems get more and more and more complicated, for example, in physics or in more advanced mathematics, the question becomes, do I multiply or do I divide by all these multiple different conversion factors? And here's what the bridge method does for you. I want to eliminate miles and I want to be left with kilometers. Agreed?
It is?
Is there signs?
If I divide by 1.62, have I eliminated miles and am I left with kilometers? Kind of?
No.
Kind of not at all. Because what I actually have here for units is miles squared per kilometer. What do you mean,
Yep.
Miles times miles is miles squared divided by kilometers. Miles squared per kilometer. What is 150 divided by 1.62? Somebody with a calculator, go.
No, I already messed it up.
0 point. No.
Wait, give me a second. I'll put 15. Give me a second. I got
Guys, do we agree? 92.3-ish?
92.6.
Yeah. If I were to tell you that the distance from my house to Seattle was 92.3 miles squared per kilometer, what do you think your reaction might be?
Ah, yes, of course.
What the heck are you talking about? Comes to mind, right? But since I know that that doesn't work, I can instead write 1.62 kilometers per 1 mile. And because I have miles on the bottom of a fraction and miles on the top of a fraction, what's miles divided by miles? 1. It's not nothing.
Well,
It's 1.
You get to leave it out though.
Anything divided by itself is 1, including units. Agreed? So now I know that it's 150 times 1.62, which is 212 plus 32, 243.
We did this exactly in chemistry.
Good.
It says Fishbone.
Because she's silly.
Oh, is he?
He's silly too.
Tell him that.
They're both silly.
Fishbone does make sense.
Guys, the bridge method allows you to be sure that you have done the problem correctly, because if the units are what you want them to be at the end, there's a good chance that you put in everything correctly. And you're just dealing with fractions. Everything multiplied across the top, everything multiplied across the bottom. You get yourself an answer. Fair enough?
Yeah.
Hang on just a second. If we have time to do a unit conversion problem. Give me just a second.
I forgot.
All right. Let's very quickly then look at another more complicated example.
Yeah.
I have 1 liter of gas.
Oh my gosh, too.
Oh, that's what you called it.
And I want to convert this to ounces. Here's what I know. There are approximately 3.6 liters in a gallon.
Oh.
That's really annoying.
Oh, he's gonna make us.
You wouldn't have to do this.
I sort of feel like when you're going to play a movie in your classroom, it's your responsibility to close the door of your classroom so that everybody else doesn't have to close the doors of theirs to compensate. Guys, there are approximately 3.6 liters. That's sort of vaguely what I remember. It's not exact, and maybe, no, I don't care. I also know that there are 128 ounces in 1 gallon.
Oh.
So what I can now do, and this is where the name fishbone comes from, but it's more properly called the bridge method because chemistry teachers are just wrong a lot. I'm going to do 2 conversions. First of all, I want to get rid of liters. So I need there to be liters on the bottom of my bridge and gallons on top of my bridge. And then I want to get rid of gallons, which means I need to put gallons on the bottom of my bridge. And I need to put ounces on the top of my bridge. What happens to liters? Cancels out because I got 1 on top, 1 on bottom. What happens to gallons? Because I got gallons on top, gallons on bottom. The solution is that 1 liter is 128 divided by 3.6 ounces. Whatever 128 divided by 3.6 is. What?
I said, I remember doing this in 8th grade science.
Good. Good.
I remember doing it in 10th grade science.
When you were in my class in 8th grade, you
Yeah, we did.
Wow, I still don't care at all. It's the least interesting conversation I've had today.
Do you know who Mr. Claus is?
What?
Do you know who Mr. Claus is?
No.
Really? Do you know any of the middle school teachers?
Why would I want to know middle school teachers?
Don't you guys have like meetings?
No,
What about the elementary?
no, even
So
worse.
it's like, I'd talk to your high school teacher.
Yeah, the middle school teachers
Yeah,
always say
whenever
they
you
talk
talk
to us.
they're like, we talked to your high school teacher and they say you're not going to succeed.
It's
Yeah,
true.
It's like, this is gonna be way harder in high school. I talk to Miss Rice all the time.
I actually do talk, we talk to the middle school math teachers, but the rest of them, not so much. I don't even know who any of them are. I know the math teachers down there. I know Mr. Zegers. I know Mr. Bryan.
Mr. Bryan, I think left, and let's see the sun.
I think he retired.
Yeah, that was his last year, I'm pretty sure.
Yeah.
I miss Clark.
You know who Miss Arnold is?
Clark's still a teacher?
So, here's one more question for you. If you were to go out into the middle of that field and lie on your back and open your mouth, how long would it be on average before a bird pooped in your mouth?
I'm probably waiting like
20 minutes.
Guys,
that's a bad look.
This is a unit conversion problem. This is a unit conversion problem. And I'm going to draw a bridge. How many mouths do you have?
Mouth?
One.
How many poops do you need?
One. Yeah. One mouth?
1 mouth per poop.
Yeah.
Agreed?
Uh-huh.
Good. Sorry, I got that upside down.
I think he's really bad at this.
It does.
There is.
Yeah, he said there's no.
The next one's gonna be like birds per square mile.
We're going to get to birds per square mile, but first we need to know how big our mouth is. Turns out that on average, remember, if we assume that your mouth when you open it is a circle, we got 15 square centimeters, roughly. So we've got one mouth per 15 square centimeters. Now, you know how many birds there are in the world?
One.
Yeah. About 300 billion.
How many?
300 billion birds in the world. 300, 1, 2, 3, 4, 5, 6, 7, 8, 9 birds. You catch each one and you dip its paw into purple ink like the elections in Iraq, and you let it go and you catch the next one. No, they estimate. Any idea how big the Earth is? Any idea how many detentions you're gonna have to do? More than one?
Isn't it like
Would you like it in miles?
100,000 square miles or something like that?
Do we count that? Since it's like how
We're gonna do it in square kilometers.
Oh, it's gonna be like
Okay.
1 million.
And because it's a sphere, it's 4 times 5 times the radius squared, square kilometers.
I hate this.
And the radius is 6,371
Kilometers?
kilometers.
Kilometers?
So let's think what we got so far, units wise. Miles are gonna cancel out.
Uh-huh.
Well, right now, that's the only thing that's gonna cancel out, but we do have square centimeters and square kilometers, agreed?
Yeah.
So, how big is 1 kilometer squared? Well, there's 100 centimeters in a meter, and there's how many meters in a kilometer? So this is 100,000 centimeters squared.
Cancel out.
Oh, look, the centimeters are going to cancel out, the centimeters squared, and the kilometers squared are going to cancel out. So far,
We just have poop.
we've got poops per bird. But here's the problem. I don't know why everybody feels the need to start ignoring me and packing up their stuff with 4 minutes still to go. There's no reason you can't just sit here and listen and enjoy the conversion. Do we agree that birds don't poop 24 hours a day?
Yeah.
Not consistently.
Yeah, no, it turns out they got to sleep for about 8 hours. So we're going to need a couple things here. The other thing we need to know is how often birds poop, and it turns out that's about once an hour. Yeah, once an hour. So here's what we got. Every bird hour, we will get 1 poop.
Okay.
You guys know what a bird hour is? You know what a man hour is?
1 hour?
A man hour is how much work one man can do in 1 hour.
What?
A man hour is how much work one man does in 1 hour. So if you are making widgets, and you can make 28 widgets in an hour, that's 1 man hour's worth of work. Which means that 2 people should be able to make 28 widgets in half an hour. 3 people should be able to make 28 widgets in about 1/3 of an hour, and so on. So when we say 1 bird hour per 1 poop, that means that 1 bird for 1 hour generates 1 poop. Hey, look, we just got rid of poop and we just got rid of birds and we're down to hours.
Okay.
But birds don't poop, as we said, all day. They're going to have to sleep. So it turns out that they sleep for about 8 hours, which means that they're pooping for about 16 hours.
They poop 16 times a day?
You don't?
No.
That's not healthy.
I do.
That's not healthy.
Now, this will tell us how many days we would have to lie on our back in the field before a bird would poop in our mouths. But it's going to be a very large number, so it might be useful to turn that into years. How many days in a year?
365. It's actually like 364 and that's changed.
65.2.
So let's see what we got. Oh, our units are years.
Okay.
So, how do we do this calculation? 4 times pi times 6,371 squared times 100,000 squared, everything else is a 1. And on the bottom of our fraction, we've got 15 times 300 billion times 16 times 365. Top divided by bottom will tell you the number of years you would have to lie out there on average before a bird poops in your mouth.
I'll do it. You have the answer?
Calculate it.
Take a picture, get out your phone, take a picture, come back tomorrow with your answer.
Extra credit?
It'll be worth points, not extra credit.
You said it, not me.
I'm totally gonna ask you to come back with a number tomorrow. Totally gonna ask you to come back with a number. I wanna know how many years before a bird poops in your mouth, on average.
What'd you say? I did or you did?
You.
Wait.
I will go sit.
Are you not waiting for me? That's messed up.
I will go sit.
You might wanna do the calculation first, Cameron, just in case you don't have the spare time.
Oh, I'll do it. I'm gonna come back with those credits. I need them.
Well, I hope so, because I'm gonna grade this.
If I lay in the field,
Let's see.
Was that Nate?
do I get extra credit if I lay in the field for that long?
I would give you extra credit if you lay in the field and a bird actually poops in your mouth.
Okay. I just gotta lay bar over myself. I'm stupid.
You look like Maris, huh?
What's that?
You also look like
Yeah,
Maris.
Maris is awesome. I didn't even say I didn't. I know, when did I say I did not like Jesus? I like Jesus. I like
You
Jesus.
just get mad.
You seem like a good guy. No, I just want you to shut up every once in a while.
So like it, we actually have to do.
We
Yeah,
actually have to do it.
Yeah. I mean, guys, just typing numbers into your calculator. We just,
So
Oh.
much work.
uh,
Thank you.
Hey, you guys have a great day. Hey, Jack. Hey, Justin.
I will see you.
Hey, person I'm running out. Hi, Carter.